Welcome back, Rashid here. Today's video is going to be mainly about um, introducing the concept of multi-cycle timing. But what we will do is we will talk about the same frequency on launch and capture. But before I start looking into that, there's a one concept that I forgot to mention last time. Okay, so a little bit continuity of the previous video. Actually, it's a complete continuity, but some of the topics that I missed from the last video. Okay, that's what I meant to say. So we generated 1 gigahertz clock that was with create clock. This was with create generated clock, and this 250 megahertz with create generated clock. I forgot to show you these waveforms, but you can see that this clock is divided by 2 of this. This clock is divided by 2 of this. So whenever you think of divide by 2, think of period is has increased. So period is here to here, which is 2 times of this. And this one is 2 times of that. Make sense? Okay, one concept. Let's look at this picture. So we have a PLL. I just created a little bit different schematic here. But you can think of PLL comes, it generates 1 gigahertz clock. Now this clock comes directly to divide by 2 and divide by 4. This one divided by 2 generates 500 megahertz. This one generates 250 megahertz. Just assume we have something. Maybe divide by 3. Okay, whatever. That's not the important thing. The important thing is something else that I'm going to say now. So these two come to a multiplexer. And then the output of multiplexer goes to a divider. Clock input of a divider. Another divide by 2. And the output of divider then goes to a lot of flops. So you define already a create clock here, then you define a create generic clock here and generic clock just like in the last video. But now we have a third divider here. And this divider, okay, if we don't have a divider, what's going to happen first? If we don't have this divider here and we have a straight connection to all the flops, we will have both these clocks reaching there. Right? But by putting a divider here, and we know that, okay, let's make another assumption. I'm just making an imaginary case, and this might not be the real case, but real cases can become very much like this. For example, in Ethernet controller, you will have a lot of clocks, and you will have some scenarios, something similar to this one. So let's say I want to have a generic clock here, but I want to have generic clock based off this one only. The two go through the mux, so I'm assuming I'm gonna keep this mux for this design. Maybe this design came from a legacy reason and I'm not using this clock, or maybe rarely use this one. But where I want to have these flops constrained is relative to this clock, because a divide by 2 of 4 will be even slower, right? So as long as I can meet timing on this clock, I will ensure I meet timing of this clock. Make sense? So if you have a 500 megahertz, 250 megahertz, so from setup point of view, if you can ensure 500 megahertz timing is clean, 250 megahertz will be clean actually, generally speaking. So I'm just defining 250 megahertz and the second version of it. So what I do is I create generic clock dash name, this one, and source I'm defining, let's say here source. There are different ways of always. I mean, you can define clocks in very different ways. As long as those serve the purpose, I mean, you want to make sure you have this delay included and then this day included. So you're not blocking any critical clocks, you're making sure all the required clocks, because your job is to make sure all required clocks reach there, and then tool's job is to do a thorough reporting on that. So source, I'm putting this one, this is the source, but source you have 2 clocks coming in, right? Multiplexer will have a timing of from here to here, here to here, so by default both these clocks will reach there. This clock is a master, these are 2 generator ones. So this one assume only these clocks go from there. I mean these clocks, I have this component here too. I mean timing relation to that one too, what I mean. So, but there are two clocks. So with the dash master, you can mention which clock you really want to use for this divide by. And then you need to say divide by 2. Dash divide by, sorry, 2. And of course, where you need to mention the pin. Okay, so that was something I wanted to mention in this video. Should I stop this video here and do the next topic with a different one? Okay, yeah, maybe. I think that this was a completely different topic. So this was a quick video. Let's stop it here, and the multi-cycle one we will do in the next video. Sorry.